Hi everybody, welcome to static routes. In this video, we are going to discuss about static routes, a very important topic as far as routing is concerned. So if you are talking about routing, so static route is going to play a very important role here. In this video, we are going to discuss what is a static route. Then we are going to discuss about what are the types of static routes available. So there are four different types of static routes available, and we are going to configure the static routes in packet tracer. So if you see the types, the four types are standard static route, default static route, summary static route, and floating static route. Now, so a standard static route, it is to connect a stub network as fixed by the administrator. So it means, so two networks, or we can say two subnets. So this could be connected by using a static route. So the administrator is going to write a command, a normal command. Okay, the administrator is going to write some command for that, and these two networks will be connected. So this is going to be a standard static route. So what is a default static route means? In a default static route, suppose if a packet is not finding a match, okay, if a packet is not finding a match for a particular path, so default, okay, what you are going to do? So by default, we are going to forward the packet to some other interface. Okay, a default static route is a route that matches all the packets. It's going to match for all the packets. A default route identifies the gateway IP address to which the router sends all IP packets, that it does not have a learned or a static route. Suppose if there is no static route, so automatically we are going to send the packets in the default. Okay, you will understand very clearly in the configuration while I'm doing the lab, you will understand it very clearly. Now, so usually the default static route will start with 0000. So this is called the any network. Okay, so this is the default static route. If there is no path exists, automatically the packet will be forwarded in the default route. So the third type is summary static route. So what is a summary static route means? So instead of creating a individual static routes, we can make it as a summary. For example, you can see here. So we have four networks here. So 172.20.00, 172.21.22.23. So instead of creating four static routes, so what we can do, we can make it as a summary. So the summary is, so 172.20.0.0/14. So this is going to be the summary. So summary, we can say in the other way, you can say when you are having subnets. Okay, so 3 or 4 subnets you are having. So for individual subnets, okay, you can create the static routes, or you can just make it as a summary. Okay, you can make only one route by changing your subnet mask. That means the CIDR will be changed. So by changing the CIDR value, you can make a single route. Okay, that is going to be the summary. Then the fourth type is a floating static route. So what is a floating static route means? You can have one more static route. Okay, for example, you can see here in this case we are creating a static route. Okay, this is my source. So and this is my destination. Headquarter router is my destination. So I'm creating a static route. Okay, in this way. Now one more static route also I'm going to create. So I'm going to have two static routes. Okay, to reach this router. Why? What is the reason means? Suppose if there is any problem, okay, suppose if this route failed, automatically the other one will be used. Okay, so this concept is called, okay, we can say it is a backup route, or we can say it is a what is it? Duplicated, okay, a duplicated or a backup. Okay, so this concept is called the floating static route. So floating static routes are static routes that are used to provide a backup path to the primary static or the dynamic route. So it is in the event of link failure. So if there is any problem in this route, if there is any problem, any failure, so automatically the next route, okay, it will be used. So floating static route is only used when the primary route is not available. So the floating static route is configured with a higher administrative distance value than the primary route. So that means we are going to play with the administrative distance value. So in the previous lecture, we discussed about the administrative distance value. So if it is directly connected, the administrative distance value will be 0. So for a static route, the administrative distance value will be 1. So here we are going to create a floating point, that means floating static route. So with a higher administrative distance value. Okay. So because we don't want to use the second static route. Okay. First static route should be used. The administrative distance value will be 1. So it will be used. So second static route with the higher administrative distance value, so that suppose if the first one, if the primary one is failed, okay, the second one will be used. So these are the 4 different types of static routes available. So we are going to configure by using packet tracer. In this lab, we are going to use this topology. So the first thing, you must know how many networks available. Okay, if a topology is given to you, so the first step what you have to do is you have to find how many networks available in that particular topology. Now, if you see this topology diagram, so we have 1, 2, 3, 4, 5, 6, 7 and 8. So there are 8 different networks available here. So already I fixed the IP address. Okay, this is the IP address we are going to use. Okay, so this is going to be the 10 network, 20 network, 30 network, 40 network, 50 network, 60 network, 70 network and 80 network. Now, I already fixed the IP address. What is IP address I need? I already fixed. So you have to do the same thing. Suppose in the exam, okay, so you have to write everything. Okay, better you have to write all the IP addresses in the paper. Then start doing. So it will be easy for you to manage. Now, so for the PC, I want to give the 10.0.0.1 and gateway for this PC is 10.0.0.2. So like this, already the IP address, okay, all the IP addresses are given. So I'm going to follow the same IP address. So step number 1 is designing the topology. So the designing is already completed. I have done that. So I'm going for the second step. Step number 2 is configuring the IP address. So now let me configure the IP address for all the machines, okay, and all the devices, everything. So I just go to the PC, desktop, IP configuration. So the IP address for this PC is 10.0.0.1. Then subnet mask 255.0.0.0 because it is class A, and default gateway. So the default gateway is going to be the IP address of your router. So in this case, it is going to be 10.0.0.2. So 10.0.0.2. Okay, so we configure the IP address, static IP address for PC 0. Now, let me go to the router. You can just place your mouse here, mouse pointer. So, fast Ethernet 0 by 0. So, I'm going to the router, config, interface, fast Ethernet 0 by 0. So, the IP address is 10.0.0.2 is IP address. Then, subnet mask and make the port status on. Now, so this is okay, we have completed 10 network. Okay, IP configuration is over for the 10 network. So let me go to the 20 network. So first you must know the name of the interface. So just keep your mouse pointer. So it is telling serial 3 by 0 with the clock rate. Okay, 3 by 0 with the clock rate. So I'm going to the router, serial 3 by 0. So here the IP address, already the IP address is written. Please kindly follow the same IP address. So 20.0.0.1 is IP address, subnet mask and default, clock rate. Yeah, default clock rate, you can give 64,000 as a default clock rate and make the port status on. Now, so I'm going for the next interface. This is serial 2 by 0. So let me click the router. So go to config, serial 2 by 0. So here the IP address is, so 20.0.0.2 is IP address. Okay, subnet mask. And here there is no clock rate. So I'm going to select not set, make port status on. So 20 network is also ready now. So let me go for the 30 network. So kindly know the name of the interface, serial 3 by 0 clock rate. So I just go to the router, 3 by 0 IP address. So the IP address is 30.1. So 30.0.0.1 is IP address, 255.0.0.0 subnet mask, clock rate. So I'm going to make the clock rate 64,000 is a clock rate and then make port status on. Then So the other end, it is going to be serial 2 by 0. Okay, so let me click the router, go to serial 2 by 0. So IP address, it is 30.2 is IP address, 30.0.0.2 is IP address, subnet mask, and here we don't have any clock rate, so I'm just going to make it as not set, port status on. So we completed the 30 network. So let me go to the 40 network. Here it is serial 3 by 0 with the clock rate. Now I'm going for 3 by 0. IP address is 40.1. So 40.0.0.1 is IP address, subnet mask 255.0.0.0, and clock rate. So this is with clock rate, the default clock rate I'm taking. So 64,000 is a default clock rate I'm taking, make port status on. Then the other end is going to be 3 by 0. So this is 40.2. So let me go to 3 by 0 IP address. So IP address is 40.0.0.2, subnet mask. You can make not set clock rate and then make the port status on. So we completed the 40 network. Let me go to the 50 network here. So here the name of the interface serial 2 by 0. So let me go to serial 2 by 0. IP address. So IP address is 50. So 50.0.0.1 is IP address, subnet mask. Then, so this is with clock rate. So I'm going to use it, okay, 64,000 and make the port status on. So the other end is 2 by 0. So click the router, config 2 by 0. So I'm just going for the 2 by 0 interface. So the IP address is 50.0.0.2 is IP address, subnet mask. So clock rate not set, make port status on. Okay, so we completed 50 network. So let me go to the 60 network. So the name of the interface serial 3 by 0 with clock rate. So let me go to 3 by 0. IP address, it is 60.1. So let me give the IP address. 60.0.0.1 is IP address, subnet mask. So clock rate, default clock rate 64,000 I'm taking. So port status on. Then the other end is 2 by 0. So go to 2 by 0, serial 2 by 0. So the IP address 60.0.0.2. 60.0.0.2 is IP address. Okay, so 60.0.0.2 IP address, subnet mask. So here we don't need to fix any clock rate here. So make port status on. So we completed the 60 network. Let me go to the 70 network. So here it is serial 3 by 0. So 70.1 with the clock rate. So serial 3 by 0. IP address is 70.0.0.1 is IP address, subnet mask. So the default default clock rate, so let it be 64,000. So make port status on. So the other end, it is going to be 2 by 0. Go to 2 by 0. IP address is 70.0.0.2, subnet mask, not set. Okay, clock rate and make port status on. So we completed the 70 network also. So let me go to the last one, which is the 80 network. So let me go to PC1. Okay, so desktop, IP configuration. So here the IP address is 80.0.0.1 is IP address, subnet mask. So default gateway. So default gateway is 80.0.0.2. Okay, so that is a default gateway. Now, the next one, we have to fix the IP address for this interface. That means for the gateway. So this is fast Ethernet 0 by 0. So now I'm going for fast Ethernet 0 by 0. IP address 80.0.0.2. Okay, subnet mask, make port status. So IP configuration is over. So we have configured the completely for all the interfaces. Okay, we fix the IP address. Then the next step is I want to give a ping command, okay, or I want to send a packet from the first network. That means from the 10 network to the 80 network. So I want to send a packet. Okay, so that means I want to give a ping command from PC 0 to PC 1. Okay, so let me go to the PC. I'm going to the command prompt. So in the command prompt, I'm going to give the command ping 80.0.0. Okay, so I'm giving 80.0.0.1. So I want to give a ping command to the last machine. So now you can see. So reply from 10.0.0.2. So who is 10.0.0.2 means? That means your gateway. So your gateway is telling destination host is unreachable. So that means your gateway is telling, so it is not having any route, okay, to the destination. Your destination is, okay, 80.0.0.1. That means 80 network is your destination. You want to go to 80 network. But what your router is telling, that means your gateway is telling, means there is no path exist. Okay, so how can we confirm this? Now go to the router. Okay, in the router, I'm just going to the CLI, command line interface. So in the command line interface, okay, I am in the specific configuration mode. Just give exit, and this is the global configuration mode. Okay, exit. Now, so here I'm going to give a command. Okay, the command is show IP route. So this command will display the routing table. So I want to see the routing table. Okay, now I'm just seeing the routing table. If you see the routing table, only there are 3 lines available. So what is that means? C, C, C. C means it is connected. It is directly connected. Okay, it is directly connected. So that means you see there are 3 networks directly connected here. 10 network is directly connected, 50 network is directly connected, and 20 network is directly connected. So only there are 3 paths available, 3 routes available. Okay, 10, 20, and 50. Okay, so in the routing table, so you have the route for 10 network, you have the route for 20 network, you have the route for the 50 network, but you don't have the route for the 80 network. So your packet is coming here, okay, from PC 0, the packet is coming to the router 0. So in the router 0, the router is asking, where do you want to go? Okay, where do you want to go? So I'm telling, that means my packet says, I want to go to 80 network. Okay, I want to go to 80 network. Okay, now they are checking in the routing table. So in the routing table, 10 network is available, 20 network okay is available, 50 is available. So the information about the 80 network is not available. So because of that reason, okay, that means your gateway is giving a error message. So it is telling, okay, destination host is unreachable. Okay, so we can see the same thing, okay, by using the simulation. So let me go to the simulation. So in the simulation, I just remove, edit, show all or none, all the protocols I'm going to remove. I'm just going to take, okay, only ICMP protocol I'm going to take. Okay, because we are going to use the ping command. Okay, so we are using the ping command. So only ICMP protocol is enough. So I just select ICMP protocol. Now, so I'm going to send a packet from PC 0 to, okay, PC 1. Okay, we are going to give a ping command now. Okay, so now you can see, I just go and take a PDU here. Okay, from PC 0 to PC 1. Okay, I'm just giving a ping command and just give auto capture. So that means you can play this. So the packet is coming to the router. So in the router, they are checking in the routing table. No information about 80 network. So you are getting a error message. A ICMP packet will be sent. A error message will be sent to you. So now what I am going to do means I am going to configure a static route. So actually in this lab we are going to see only two static routes, 2 types. First 2 types. Okay, so one is the normal, the default, okay, normal static route, and second one is the default static route. Okay, only 2 things we are going to discuss in this lab. Now, so I want to create a static route. So what I want to, how to create a static route means, now I want to, okay, create a static route from 10 to 50 first. Okay, from this to this. That means router 0 to router 1. I want to create a static route. Then from router 1 to router 3. So router 3 to router 5. So static routes will be created manually by the administrators. Okay, so an administrator is going to create, okay, the static routes. So for each and every router, we have to go to each and every router and we have to configure the routers. Okay, the administrator must type the commands and create. So now what I'm going to do, so let me go to the, okay, come to the real time. So in the real time, now I'm going to configure, okay, the static routes I'm going to configure. Okay, so let me go to the router. So I'm just going to the router. So in the router, let me go to the CLI, command line interface. So I'm in the user mode. I'm giving the command enable. Then, so let me go to config terminal. Okay, that means global configuration mode. I am in the global configuration mode. Now I'm going to create a root. Okay, so how to create a static root means, okay, IP. Okay, this is the command IP root. Now I'm just giving a question mark. So to show what will be the next IP root. So A.B.C.D. Okay, that means your destination IP address. So my destination is going to be 80.0.0.0. Then the next one is going to be subnet mask. Okay, no issues. I'm just giving a question mark. You can see here destination prefix mask. So you need to give the destination subnet mask. So the destination subnet mask is 255.0.0.0. Okay, so this is the destination subnet mask. Then I'm just giving question mark. So the next one is going to be the forwarding router's address. So that means, so what is going to be the next hop? Okay, you are here. So the next jump, I want to make it, okay, to this router. That means I want to make a jump to 50.0.0.2. Okay, for this IP address, I want to make the jump. So now my next jump is going to be, so 50.0.0.2. Okay, so just enter, the root is created. So what it says means, if a packet comes here, okay, so the router is going to check what is your destination IP address. So if the destination IP address is 80, so automatically your packet will be forwarded. Okay, it will be forwarded to 50.0.0.2. So that means your packet will reach up to this now. Okay, so we will check it. Okay, I'm going to check it whether it is okay working or not. So let me go to the simulation. I'm going for the simulation. So let me give a ping command from PC0 to PC1. Okay, let me give the ping command. So I'm going to take, okay, the PDU. So from PC0 to PC1, okay, I'm giving the ping command. So now you can see auto capture. So now the packet should move up to router 1. Okay, now from router 1 to router 3, we have to create a static route. Then from router 3 to router 5, we have to create a static route. So if you create from 3 to 5, automatically it will reach. Okay, it will reach the 80 network because 80 network is directly connected here. Okay, so 80 network is directly connected, so there is no problem. It can, up to router 3 to router 5. If you create it is enough. Okay, so now let me just delete this scenario. So let me go to the real time. Now I'm going to create a static route from router 1 to router 3. I'm going to create a static route now. So let me go to router 1. Then I'm going to the CLI, command line interface. I'm going to use the command enable config terminal. Now I'm going to use the command IP root. I'm creating a root. So my destination is 80.0.0.0. Okay, so subnet mask is 255.0.0.0. Then the next one is, okay, the next hop. Okay, that means the next jump I want to make to 60.0.0.2. So 60.0.0.2. Okay, so this is the IP route. So now your packet will reach up to router 3. Now you can see the routing table. Okay, let me show the routing table now. I'm going to use the command show IP route. So now if you see the routing table, you can find, okay, a static route is created. Okay, static route is created. As I already told, okay, you can see 1 is the administrative distance value. Okay, if the administrative distance value is less, then that route is going to be very strong. So for directly connected, this is directly connected. For directly connected, okay, networks, the administrative distance value is 0. Okay, it is 0. That's very strong. The next one, okay, the next one is going to be the static route. So we are going to discuss some routing protocols in the coming lectures. So if you see the routing protocols like RIP protocol, okay, if you use any RIP protocols, you don't need to do any configuration like this. If you enable the protocols, it is enough. But for the RIP protocol, the administrative distance value will be 120. Okay, so if the administrative distance value is increasing, means it is not going to be reliable. Okay, so if the administrative distance value is less, that particular route is going to be very strong. Okay, it is very reliable one. Now, so up to router 3, okay, we created the static route. So now let me go to the router 3 now. So CLI command line interface, enable config terminal. Now I'm going to create the route, IP route. So my destination is 80.0.0.0, 255.0.0.0. So this is a subnet mask. So now I want to make the next jump, I want to make to 70.0.0.2. So 70.0.0.2, okay, that is going to be the next hop. So now your packet will reach the PC1. Okay, it will reach PC1. Okay, so let us try. Okay, I'm going to check it by using the simulation. So let me go to the simulation. I'm going to, okay, use the PDU. So let us give a ping command from PC0 to PC1. So now let me give the auto capture. That means play. So the packet will go to the destination, but while coming back, okay, you can see. So ping command means you have to get a reply. Okay, echo request, echo reply. You must get a reply, but here you can see, okay, whether you are getting the reply or not. So there is no issue here. There is some problem coming. Okay, nothing. Just you can delete it. So this is because of the ARP protocol. So I just delete it. I'm going to issue the ping again. Yes. So the packet reached the destination, but I have to get reply. Okay. So that is the concept of ping. Now, while coming back, okay, we are getting the error. So what does it mean? That means, so your packet is reaching the destination, then the reply packet is coming to the router 5. So now, what is the destination IP address? Okay, for the packet, now the destination is going to be 10. So the packet wants to go to 10. Okay, that is the reply. Now they are checking in the routing table. So in the routing table, there is no route available for 10. Okay, so here 3 networks directly connected. You can say 40 is directly connected, 70 is directly connected, 80 is directly connected. Plus we created, okay, for 3 networks directly connected. But here there is no path available for 10. Okay, there is no route available, okay, for the 10 network. Okay, if you want to check, so just I'll delete this scenario. Let me go to the real time. You can see here, I just go to the router, CLI, display the routing table. In the routing table, okay, you will be having only 3 lines. That means only directly connected networks will be available. Show IP route. Okay, you can see 40, 70, 80 is available. So there is no 10 network information here. So while coming back, the packet wants to go to 10 network. So that is the destination. So 10 network information is not available here. So what we have to do means we have to create a static route here for 10 network. Okay. So let me create a static route, okay, for 10 network in router number 5. So now here we are going to create the static route. Okay. So from PC0 to PC1, okay, we forwarded the packet in this way. So now what I'm going to do, I'm going to get the reply in a different way. Okay, I'm going to change my path. Okay, because this is static. You can create your own path. Okay, for example, so the packet was going like this. Okay, so the packet reached the destination in this direction. But now the reply, I want the reply, okay, in the opposite direction. I want to bring the reply. Okay, so my reply should come in this way. So a administrator can do this. Okay, administrator can do this. So very easily a administrator can do this particular. Now, so I'm going for router. Okay, router 5. So let me go to the CLI command line interface. So go to the config terminal in the configuration mode, global configuration mode. So in the global configuration mode, now I'm going to type the command. So IP root. So my destination is now 10.0.0.0. So subnet mask 255.0.0.0. Then we are going to give the next hop. Okay, the next hop is very important. So you can give the next hop here. So we are here. So the next hop is going to be 40.1. So 40.0.0.1 is the next hop. So you can use IP address or you can use the name of the interface also. Okay, so you have to find what is the name of the interface, serial 2 by 0, 3 by 0 also you can give. Better go with IP address in the beginning, okay, in the initial stage, okay, go with the IP address, that will be easy for you. Now, so I created the route. Now, okay, now the packet will go to the destination, then it will come up to router 4 because we created a static route here. Then from router 4 to router 2, okay, I want to create a static route. So let me go to router 4. I'm going to the CLI, command line interface. So now I'm going for enable config terminal. Okay, so IP route. My destination is 10.0.0.0. Okay, so that is my destination. Now, so 255.0.0.0. Okay, so what is my next hop? I am in router 4. Okay, I am in router 4. So my next jump is going to be 30.1. So that is the next hop. So the IP address is 30.0.0.1 is the IP address. So now you can see the route is created. Now, so your packet will reach up to router 2 now. So now from here, I want to create a static route. Okay, so let me go to router 2, command line interface. Okay, enable config terminal. So we are in the global configuration mode. So IP route. So my destination is 10.0.0.0. Subnet mask is 255.0.0.0. Okay, so we are in this router, that means router 2. So the next jump we are going to make it for 20.1. Okay, that is IP address. So 20.0.0.1 is the IP address. So now you can see we created the route. So if you check now, if you give a ping command now, so automatically your packet should go in this direction. Okay, it will reach 80.1 and reply. Okay, echo request will go like this, echo reply. Okay, the reply for the ping command you will get in this particular path. So this is called a static route. So static route will be created by the administrator. There are some advantages available and disadvantages available here. So advantages means if your network is very simple, okay, if you're having a topology, very less number of computers, it will be very easy to manage. Suppose if you are having more number of networks, means it will be difficult to configure. Okay, but it is going to be strong. Okay, it is more reliable. The route is going to be very reliable one. Okay, because the administrative distance value is 1. So let us try the ping command from PC0 to PC1. So I'm going for the simulation. So let me give you a ping command from PC0 to PC1. So your request will go like this, okay, and reply will come in the opposite direction. So let me just give the PC0 to PC1. You can fix your own path here. If you use routing protocol, the routing protocols will decide the path. Okay, it will decide the path for you. But here you are going to create your own path. Okay, so you can decide how your packet should move in the topology. So that is decided by the administrator. So packet is going to router 3, then router 5. So it reaches the destination. So echo request. Now we are going to get the reply. So this is a reply packet. So the reply packet is coming in the opposite direction. Yes, so successfully we created the static route. Now the next type of route, okay, that means in static route the second type we are going to create. Okay, actually in our labs two only we are going to discuss in this lab. Okay, in this lab only the first, okay, the normal static route, Then the second one is the default static route. Okay, so now I'm going to create a default static route. I'm going to create. So let me go to, okay, so delete the scenario, go to the real time. Now, what is default static route? So default static route means, suppose if a packet is not finding the route, okay, for example, in this router, we are having 10 network directly connected, 15 network directly connected, 20 network directly connected, plus we created a static route for 80. Now, a packet is coming, okay, I'm sending a packet to 90 network, okay, for example, imagine 80 is there, okay, instead of 80, I'm going to make this as 90. Now, so the packet is going to come to the router. So in the router, they are going to search in the routing table. Okay, so I want to go to 90. So 90 information is not available. If 90 information is not available, so what I'm going to do, forward it in some path. Forward in some path. Okay, now what I'm going to do, so I'm going to create, okay, suppose if you're not finding anything, okay, if you're not finding a particular path, so what we have to do? So that is going to be the default route. So if I'm not finding any path, no need to hold the packet or no need to drop the packet, just forward it in some interface. Okay, just forward it to some interface. So what I'm going to do now, I'm going to change the IP address of this network. So I don't want to make it as 80. Now let me change it as 90. Okay, I'm going here. So IP configuration. So the IP address, I'm going to make it 90. Now the default gateway also, I'm going to make it as 90. Okay, so let me make it as 90. So now here we have to change the IP address. So fast Ethernet 0 by 0. So let me change the IP address fast Ethernet 0 by 0. I'm going to make it 90. Okay, so this is a 90 network now. So let us give a ping command now from PC 0 to, okay, PC 1. Okay, let me give the ping command. 100% it is not going to work because 90 information is not going to be available here. Only 80 we created the static route, 90 is not available. So now what? Okay, again you are going to get the error. So let us try. I'm going for the simulation. So let me give the ping command from PC 0 to PC 1. Okay, so now it becomes 90. The destination IP address is 90. So now you can see we are getting the error. So because the route is not available. So we are having 10, 50 and 20 plus 80 we created. But now I'm going to send my packet to 90. So automatically the packet is dropped. Okay, we are getting an error message. That means no route. You cannot find the destination. Now I'm going to configure the default route here. So what is the default route means? Suppose if there is no match, suppose if there is no route available, what you are going to do? Okay, so that is the default route. So now, so let me go to the router. So I go to the CLI command line interface, enable config terminal. Now I am in the global configuration mode. I am going to create a default route. Okay, I am going to create. So IP route. So how to create a default route means you have to use, okay, 0.0.0.0. Okay, so that is called any network. Okay, I'm just giving a question mark. So to get the help, so A, B, C, D. So it is going to be 0.0.0.0. Suppose if the route is not available, okay, if the route is not available, okay, so that is I'm going to mention as any network. Then the next one is going to be the subnet mask. So subnet mask also I'm going to give it as 0.0.0.0. Then I'm giving the question mark. So the next one is forwarding router address. So where you want to send. So a packet reaching router 0. So it is asking, I want to go to 19 network. 19 network information is not available in my routing table. So where you want to forward it? Suppose, okay, if the route is available, no issues. I want to forward to somewhere. So let me forward it to router 2. Okay, now I'm going in the reverse. Okay, I'm going in the reverse order. So let me forward the packet to router 2. So that means 20.0.0.2. So I'm going to forward it to 20.0.0.2. Okay, I'm going to forward. So this is the default route. Okay, so now let me show the routing table. Okay, I want to see the routing table now. Show IP route. Okay, so if you display the routing table, you can see already you are having a static route. Okay, you are having a static route we created. Now we are creating another static route which is going to be a default one. So this is called the default static route. So if there is no match available, automatically they will follow this. Okay, your router is going to follow this. So all the packets will be sent in 20.0.0.2. So now let me try. Okay, I go to the simulation. So in the simulation, so let me give you a ping command from PC 0 to, okay, now it is 90 network. So now you can see your packet should be forwarded in this direction and it will be dropped in router 2. So now, so the packet is going to reach router 0. Then from router 0 to router 2, okay, the packet will be forwarded. Okay, because now it is following the default route. The destination IP address is 90 now. So automatically it is coming to the router 2. Now from router 2 to router 4, I'm going to create a default route. Okay, again I'm going to create a default route. So then I'm going to give the ping command. So let me delete the scenario. So go to the real time. So in the real time, so now my packet is reaching up to router 2. We created a default route. In router 2, I'm going to create a default route now. Enable config terminal. Now IP root 0.0.0.0, okay, space 0.0.0.0. Okay, so what is the next jump or the next hop means? So we are in router 2, so I want to make a jump to 30.0.0.2. So 30.0.0.2 is my next hop. Okay, so in router 2 we completed the static route. Then from router 4, okay, I'm going for the router 4 now. So in the router 4 also the same thing I'm going to give now. So enable config terminal IP root 0.0.0.0 0.0.0.0, okay, and 255. Sorry. So the next hop, what is the next hop means? So the next hop, we are in router 4. So the next jump is 40.0.0.2. So 40.0.0.2 is the next hop. So I created a default route. Then I'm going for router 5. So here I'm going to create. Okay, now let us check. Okay, let me give the ping command and check what is the status. Okay, so based on that, because I want you to understand the things. Now, so let me go to the, okay, in the simulation, I'm just going to give a ping command from here to here. So let us see what is happening. Okay. So the packet reaches router 4. So there is a default route available. So it reaches 40.0.2. So we are getting an error. So no issues. I just delete it and give it again. Okay. So this is because of ERP protocol that I will explain to you in some other lab. Okay. You can just give the ping command again. So second time, if you are getting any error, then there is some serious problem in your topology. It is not properly configured. So it reaches the PC 1. Now the reply, okay, the reply is coming. So the reply is, okay, we want to go to 10 network. Already we created a static route. Okay, already the static route is available for 10 network. Okay, we already created the static route. So it is now using the static route. Okay, try to understand. So your echo request, the ping request is going by using the default route. The reply is coming. Okay, the reply is coming by using the static route. Okay, so this is the concept. So two different types of things we created. Okay, a normal static route we created. Then we created a default static route. Okay, thank you very much. Keep watching.